Okay, ma'am. Am I audible?
Yes, ma'am.
Okay. Thank you. Good evening to all. I, Professor Shilpa Nevare, extend a warm welcome to all the esteemed participants joining us today for this online ATAL FDP Day for You Session 1 on From Ideas to Innovation, a Patent Landscape Approach to Science and Technology Correlations. Let's get started with the first session. Today, we have with us multifaceted academician who has significant contribution in the field of academics, research, and administration. It is my distinct privilege to introduce a truly exceptional individual, Professor Dr. Parashram Shirge, a leader in metallurgical engineering and material science. Currently a professor at IIT Indore and a visiting faculty at Meiji University, Tokyo in Japan. Professor Shirge has held leadership roles including Vice Chairman of IIT JEE Advanced and Dean of Planning at IIT Indore. A visionary researcher, Professor Shirge's work is at forefront of transformative technologies that will shape the future of energy and material science. His pioneering research focuses on sodium ion batteries, next generation solar cells, air batteries, gas sensing technologies, and superconductors. His contribution to the inverse isotope effect and single crystal growth are pushing the boundaries of energy storage and material understanding. Professor Shirge's excellence has been recognized with prestigious fellowships, including JSPS and MEXT Fellowship in Japan. The Ramanujan Fellowship from India's Department of Science and Technology. His accolades includes the MRSI Medal in 2020 and the Outstanding Research Paper Award for RSC Energy Advances in 2023. An inspiring leader, Professor Shirge has delivered invited lectures and chaired scientific sessions at global conferences in Japan, South Korea, Turkey, Greece, Belgium, France, Italy, and China. He serves on the editorial and advisory boards of top journals, including those from the Institute of Physics and elsewhere. Please join me in welcoming a true luminary in material science, Professor Dr. Parashram Shirge, whose works continues to inspire and illuminate the path forward for all of us. I welcome you, sir. Now, we all are eager to hear Professor Dr. Parashram Shirge sir's insights. I now invite you for the expert talk on the topic Open Innovation and Collaborative Research and Development. The mic is over to you, sir.
Thank you, madam, for nice introduction. And I'm really grateful to all the organizers, including principal, vice principals, and Obale madam for this invitation. Let me share my presentation first. Is it visible now?
Yes, sir, it is visible.
Okay, thank you.
Sir, just give me one moment. Sorry to interrupt you.
Okay.
Shivaji Pawar, sir, do you want to keep your camera on? Okay. Sir has now turned the video off. His camera was on, so it gets highlighted. That is why I interrupted. Sorry, sir. You can continue now, sir.
Okay.
Okay.
Thank you very much once again. My health is not good, but I'll try to explain it very silently. Okay. And I think it will not break any sequence also. So this is out of my box lecture because this is not related to my research or something. This is something different. So today I will talk about the how innovation is important for the R&D work, how collaboration is important for the R&D work. Okay. So my introduction is already given by the madam, and about IIT Indore, we have 23 IITs all over this country, and in the IIT Indore is situated at this center of the me. Okay, center of this India. So this is part of Madhya Pradesh, and among these all 23 IITs, more than 80,000 students are taking admission every year for through this JEE examination. So this is the out, outskirt of our IIT Indore. This campus covers 2.2 kilometer by 2.2 kilometers area. This is academic pod here, and this is a administrative building. This is library, and like this, we have hostel this side, but that is not visible from this end. And now more than 4,000 students are studying in this IIT Indore, and 240 more than 240 faculties are there, with staff assisting staff of around 500. And we are standing 16th rank among these all institutions in India, engineering and all these things. So this is my research group. Basically, I am the product of Professor S.H. Pawar. I am student of Professor S.H. Pawar. So I took inspiration from him to guide the PhD students, and I have guided 18 PhD students so far and working 6 students, and complete 21 master students and one working, and we take 20 completed because our department started in 2026. So this is new department. So these are the alumni of my research group. They're working all over the world in different countries, and we always work in collaboration. So this will be good topic to discuss here. So basically, my research group is Advanced Functional Material Research Group. So I started my research work on superconductors. My guide, Professor S. Pawar, gave me a topic of high temperature superconductors, silent superconductors. From there, I moved to South Korea to work on these thallium-based superconductors, and it's continued till 2023. Almost 20 years I worked on this topic, and a lot of fundamental as well as application part I have completed in superconductors. Beside this, I am working on this energy harvesting materials, for example, solar cells, including first generation, second generation, third generation solar cells, and also on piezoelectric materials. Then recently I started working on these batteries and supercapacitor in batteries. I was the first to start these sodium ion batteries in this institute, as well as ministry has given some grant to start the small scale company on sodium ion batteries. Then I also working on the sensors. This is very important for some greenhouse gases detection and all these things. Also, I'm working on this matic nanoparticles for spintronic applications and other applications, which are very important for the magnetic switching and all these things in the IT department. Also, this is requires a lot of things. Okay. So coming to the main outline of this talk, this is outline, introduction to open innovation and how collaboration is important for this, the importance of the collaboration, and what are the challenges and risk factors affected with this one. Some case studies, including my own experience in this one, then future perspectives. There are four key elements in the innovation. First is collaboration. Without collaboration, it's really difficult to develop some technology or something. Only with one institution, it's not possible to develop some product or something. So we have to collaborate with others for some useful applications. Then ideation is this is another key factor. We should create the ideas. When we face the problem, then automatically idea will be there to solve that problem. Then implementation, how to implement the projects. And by using this collaboration, ideation, implementation, how to create the valuable product. Okay, that's value creation. So innovation requires collaboration, ideation, implementation, and value creation. What we can learn from this? Listen and explore. What can we do together? Then learn and adjust means how we will learn together. Then focus and align. What should we do together? Then link and leverage. What will we do together? Means what, how, what should we do and what we will do together. This is very important for the collaboration, ideation, implementation, and value creation. Okay. Now, what is collaboration? Collaboration, nothing but a teamwork is essential to getting the things done. In today's global and digital 24 by 7 world, challenges are very complex. For this solving the complex problems, we need a collaboration. It's becoming essential and important for being more diverse mind, sit on the table and break the groundbreaking research work and break down the silos. Okay. So we have a lot of problems, but in order to solve that, I am not able to solve my own problem by myself. For example, I'm a material scientist. I want to make a solar cell or some other things, or I want to generate the supercomputers. For that, I only know how to make a material. But in order to make a supercomputer or something, I need to provide my single crystals to others so that they can use that single crystal to make a supercomputer. So that's called the collaboration. The gathering of the teams together coming and solving the problems for making the product. That is the collaboration. Okay. Then ideation. We have a lot of problems, but how to solve that? Fresh new ideas help your organization to stand out. Okay. With intense competition for the resources, organization and must differentiate in order to survive. Because only with whatever traditional is going, it's not easy to survive in this computational world. We should create some new ideas to highlight in these organizations. We should take some new ideas to implement and then develop it. Okay, that is ideation. With traditional research work, it is not possible to make a R&D in that one, okay, or make new product in that one. Then implementation, what are good ideas if they are not put to use? Okay, we have to take the new ideas, then make a concrete plan of how to use it. If we do not use it, then what is the use of that thing, ideas? Okay, this is waste of the idea. Then organization must encourage the best people to champion their ideas and keep those great goals moving toward forwards. This is very important. Unless and until we use some ideas and implement it for innovative R&D, it's not possible to do it. Okay, so this is very important. And if we do collaboration, we use some ideas, then implement it, then automatically we'll get the new good. Okay, that's the value creation. That's for useful application, we can use this. So you don't have innovation if your new ideas aren't creating value. Okay, organization must implement ideas, then program identified by the most effective and delivering value to stakeholders. This is very important for the creation of this one. Okay. Then what is open innovation? This open innovation nothing but collaboration across the boundaries, then knowledge sharing, then external inputs. If we share some ideas, take the input from the other collaborative teamworks, what challenges they face, and what new ideas we can put in that one, and focus on the value creation of the things. Okay. So open innovation is a concept in research and development that involves leveraging both internal and external ideas. This is not only the one institute's idea. It should have the multiple collaborations, their institute's ideas, use their resources and technologies to accelerate the research in the innovation. If I have a material synthesis growth techniques in my institute, and I do not have the low temperature facility or testing facility or fabrication US fabrication facility, then I must collaborate with the other institutes which they have the low temperature facility, or someone has the US fabrication facility, and learn from them what they want as a material scientist from me and what I can provide them. Then put all the my resources and their resources, my ideas and their ideas to develop the product. That is called the innovation in this one. Okay. So this is the open innovation. It contrasts with the traditional closed innovation system, because closed my innovation means, okay, my institute is doing this research, I should not disclose with the other institutes. This is not good. This is traditional research work that will hide the innovation ideas, all these things. Okay. So in order to develop some good ideas, some innovations, we should always collaborate with other organizations. Okay. Where organizations rely solely in their internal resources to develop new products, service, and process. So this will hide the things. Okay. So what is the value addition in this topic is that we should collaborate with multi-organization, multi-teamworks, take their inputs. We just will share the idea with them, take the inputs, and taking the input from them, we can implement in our value creation. So this is the open innovation. So how this open innovation will help? So whether this is inbound or coupled or outbound. What is now inbound? Inbound is nothing but incorporating external ideas, technologies, and knowledge into an organization's innovation process. What is coupled? Coupled is nothing but combined inbound and outbound flows by collaborating with partners to co-create values. This is coupled. Outbound, we can share the idea with the external sharing sharing external innovation with the external partners to generate the additional value. It means that we have some ideas we can do by ourselves by sharing the ideas with other external things or technologies or knowledge and all these things, or we can couple in internal and outer agencies to work on that, or only we can give some ideas to other third party and they can execute that idea. So the meaning of this is open idea, inbound, coupled, and outbound areas. Okay. For examples, crowdsourcing, Kaggle and Open ODE. Then collaborative R&D. This is one of the very well-known example. COVID-19 vaccination collaboration. Many institutes come together to develop the COVID-19 vaccination. Okay. Then open source softwares, for example, Linux and Apache. These are the very well-known examples of this one. Okay. So this type of innovations, type of the open innovations, they are very important, either inbound, coupled, or outbound. Okay. So these are called as the open innovations. In this innovation system, we need to collaborate. From my first slide, I'm just focusing on this collaborative work. Okay. So why we need this collaboration in the R&D? If we do not do collaboration, then what will happen? If we not do collaborate with others, we'll not able to get the idea from there, or we are not able to implement our ideas because we do not have the all the sources, all the infrastructures that we need for the innovative R&D. Okay. Access to the diverse expertise. For example, collaboration unites academia, industry, and scientists, delivering diverse expertise to create the innovative solution beyond the capacity of the single organization. As I mentioned that if I am not a scientist, I do not have the low temperature facilities. then I'm not able to characterize and I'm not able to see it whether it is superconductor or not because I do not have the low delivery facility. In order to check the superconductivity is there or not, I must collaborate with the organization which has the facility to test it to temperature facility. For example, superconductors always superconduct at low temperature, liquid helium or liquid nitrogen range. If I do not have that facility, then I should collaborate with the other organizations. Then other organization only have the low delivery facility, but they do not have the facility to create the devices. Okay. For example, we must use the FIB technique, focused ion beam technique, to make the device, three-dimensional devices, all the things. Okay. So again, that we need to involve the third party also there. Okay. Then we need to bring that product into market. So we need the other organization which is very good in implementing the this all this product into market. Okay. So we need for such an organization. So this is the access to the diverse expertise. We should involve the academia, industry, and scientists. Unless and until we involve all these things, it's not possible to assess the diverse expertise. Okay. Then also we need to check whether cost and risk sharing is there or not in that collaboration. Okay. Collaboration distributes the financial risk because if we fail to do something, then only that is the institutional failure, and that whatever the money put by that organization, that will be in the risk. In order to minimize the risk, all the financial support is given to the all the agencies, and they will distribute the financial risk also. Okay. And collaboration distributes the financial risk and reduces the burden on the individual entities, enabling project that might otherwise be unfeasible. Okay. So cost and risk sharing is very important. Then accelerated innovation, sharing resources, data, and infrastructures speeds up the research process. This is very important point to be noted here. Okay. Unless and until we share our resources, our data, and infrastructure with others, it's not possible to develop it. So if we do all these things, sharing the resources, data, and infrastructure, that will speed up the research process and ensuring the faster delivery of the innovative solutions or the product. So this is very important. Accelerated innovation. Then enhanced problem solving. In this global system, complex global challenges are there like climate change or energy transition or healthcare. Are all these are the crisis demand interdisciplinary risk approaches. Okay, in order to solve this, we should have the problem. We should have the capacity to solve all the problems, complex problems related to climate change or energy or healthcare. Okay, so COVID-19 was the one of the important example to this one. All was locked down. So many institutes come together and they solve the problems. So that is one of the example of that. Then market and industry impact. So by doing this partnership with the academia ensures the access to the cutting edge research while the industry provides the market insight for the practical applications. We academicians, we scientists do only the research. So when we do research, we are not knowing that how much is the value of our product. Okay, then we should involve some industry persons. They will know how to enhance the product of that one and how to calculate the product's value. Okay, so and where is the market available and how the industry impact will be there, what product we are developing and what impact will be there. So that will be taken care by the industry. Then global competitiveness. For example, we are developing some product, but that is not so good in the global market. Okay, then it's failure. Okay. So collaborative R&D fosters innovation, ecosystems, enabling countries and organizations to remain competitive in the global market. Because we are collaborating with many countries, then automatically that will provide the platform for our product also. Okay. Then social and environmental benefits. Collaborative R&D fosters sustainability by tackling the social challenges like clean energy and healthcare. Oh, this is very important. So why we need a collaborative R&D? Because it will provide the access to the diverse expertise, and it will take care of the cost and risk sharing and accelerate the research innovation, enhance the problem solving capacity. Then it will provide the market and industry impact also. It will provide the competitiveness and social environmental benefits we'll get from this one. Okay, so that's we need the collaborative R&D. So what are the advantages or challenges of this open innovation? First, we'll discuss about the advantages. So what are the advantages of this open innovation? Access to the broader pool of the ideas and expertise. So this will provide open access to many teams, and that will take the feedback from them, and it will develop the product. And faster time to market. So if we have the multiple collaborations and they are expertise in their field, one is material synthesis, another is the characterization of that material, third one is fabricating the device, and one is industrial. Okay, so it means by collaboration we can faster it, and it the time taken for the making that product into the market, that will be very easy. And also by doing this, we have reduced R&D cost, because all the cost, whatever that will involve by at one institute, that will be divided into four institutes now, because material, then its characterization, its device fabrication, then industry. Okay, automatically the R&D cost will be lower in that case. This is one of the advantage. Then increase visibility and agility. Okay, so this is also very important. With collaboration and open innovation, this will increase visibility and agility. Okay, then enhance competitiveness. If we do collaboration, all these things, then this will enhance the competitiveness in this one, and it will solve the problems very quickly. So what are the challenges in this one? If we are doing collaboration, then automatically, now I explained about the material synthesis, material testing, then materials, device fabrication, then market. So who will take the lead in this one? Who has to claim this intellectual property? This is called the patenting. Okay. So all these four evaluations are, but who will claim the patent for this one? Okay. So intellectual property, before doing any collaborative work, first we have to take care about the IP factor. Okay. This is very important. So if we collaborate with multiple organizations, their working culture and organizational barriers are completely different. For example, if we work in the CSR lab or in IIT, their work culture is completely different. Their organizational boundaries are completely different. Even for the small thing in the CSIR, they need to take the permission from the IG or DG. Okay. For in our IT system, we are free. I'm as an independent faculty, I can do anything, whatever I want. That is the cultural and organization barriers are there. Okay. So these are called the cultural and organization barriers. So this is faced by when we do the multiple collaboration. Then coordination management complexities. If we are involving multiple laboratories, multiple countries, multiple people, team members, then the coordination management complexity will be there. Who will coordinate, how they'll coordinate, how quickly they'll coordinate. These are the challenges. Okay. So while doing this collaboration, this is one of the factors we should be taking care of this one. Then while doing all these things, how to control the quality and integration of this idea. If one we are sharing the idea with one team, they should keep idea with them only. They should not disclose to the others. That's very important. That's called the integration. When we share some ideas, they should not again collaborate with multiple institutions. That will spoil the idea of ours, whatever we have. So the quality control and integration there is very important. Finding the right partner is very important. That's why I told that when we have some ideas, we are sharing with others, they should not disclose that idea with the third party. Okay. They should keep with them. Then they should implement it. And whatever idea is given to them, they should work only on that, whether disclosing with the other institutes. Then managing the innovation process. This is also very important. And these are the challenges basically faced by the most of the collaborative team members. So we have to focus on this managing the innovation process also. Okay. So what are the best practices for the open innovation? First is what we want to do. That objective should be very clear. For example, I want to develop a battery. Then before starting collaboration, I should define my ABs to develop the battery to deliver the energy of few kilowatt per hour. Or okay, so that is my objective that I need to clearly discuss with my partners, the collaborative peoples. Okay, then I should say that I am developing this material, but I want this much capacity from that one. Then this should be the cost of that one. And if we bring that into market, then this should be our objective. Okay. So defining clear objective while collaboration, this is very important. Okay. Then foster a culture of collaboration. This is also very important. And while best practice for the open innovation, fostering the culture of the collaboration is very important. Then identifying the relevant external partners. Okay. Before collaborating or making MOU with anyone, we should know that really whether they are uh, working in our field, they are expertise in that field, or whether they are able to develop that or deliver that objectives properly in time or not. That is very important. So identifying the relevant external partners, that is very important. And when we do some collaborative work, we should have the best trust on our collaborative teams. Okay. Building trust and relationship. This is very important. And if we do not have trust, then that will develop the bad relation and that will spoil our open innovation and our collaboration things. Okay. And also embrace digital collaboration tools. This is also very important because every time we are not able to physically go there and all these things. So we have to involve a lot of things there. Then encourage co-creation and co-development. This is very important in this open innovation. So when we work as a collaborator, we always do as a one team members, even multiple people are there, but we should always work as a one team member. That will encourage co-creation and co-development of these things. Then established intellectual property strategies. Okay, and I'll clearly told that in earlier slide. Then when we develop some material or something, some properties, some devices, then who will take the lead to claim the IP, intellectual property or patent? So that is very important. So at the initial stage only, we should clearly define that this institute will take lead of this one and they will claim the intellectual property for that product development. So that should be very clear. Then facilitating knowledge sharing and learning. Whether we can share the half idea or full idea with everyone and it will create the knowledge sharing and learning process or not. That also we need to define. And once we do all these things, what will be the major and valuable impact of that product in the society? Okay, that is very important. Measure and evaluate the impact of that product on the social life. Okay. And if we adopt that, how that will evolve, how that will create the new things rather than doing the traditional things, whether that will be beneficial for this all these things or not. So that is adapt and evolve. So if we adopt that, then whether that innovation will be there or not, that we should think about them. So these are the called top 10 best practices for the open innovation. So in open innovation and target management, we should have the external idea resources. Okay, then in combination with organizational internal resources. And when we combine external and internal all the resources, then that will lead to the R&D development, and that will decreasing the innovation risk. Then that will customize the engagement of the our team members and burden on the each research teams. Then that will create the co-creation of the product. Okay. So whatever earlier I explained, this is the combination of all these things. Open innovation and target this market. If we do the multiple collaboration, then that will develop the R&D, then that will decrease the innovation risk, then that will engage the multiple teamworks, and that will put the various ideas, various expertise in that one, that will create the product. Okay, then that will distribute to the existing market and new markets. Okay, so that will target many markets in this one. Okay, so one is the one of the example is that COVID-19 vaccination development. So multiple collaboration took place to develop this vaccination. Okay, in Pfizer, Biotech, Moderna, USA and Germany, and for this AstraZeneca, this and Oxford, UK. Okay, they have developed this vaccination. Unless and until they come together, somebody has given some biomaterials. By using that biomaterials, how to attack the virus. So all these organizations, they were expert in that one. That's why very quickly, within a month, they developed the vaccination for this attacking this COVID-19 vaccination. Okay. So what was the impact of that? That accelerated the vaccination development timeline from the typical 8 to 10 years to under 12 months. If only one organization has to work on that, then it will take 8 to 10 years because we need to do the testing on the animal first, then human, then whether that will work properly or not. All these things is there, and everybody's one organization is expert in one technique, other organization is expert in other technique. Okay, so the work which was supposed to take 8 to 10 years, that was developed within 12 months. Okay, so that is the benefit of this multi collaborative R&D work. Okay, so 13 billion doses were distributed globally as of 2024. This is the data taken from the WHO. Then vaccination reduces the hospitalization by 85% in yearly trials. Okay, CDC reports. This is the okay. So there are the various vaccination developed by this in the collaborative research work of the vaccination development. Then Tesla's open source electrical vehicle patent. Now we have conventional energy resources. In order to cut that in our conventional energy resources, we should develop the electrical vehicles. And that is done by the Tesla now because the patent is shared with the multiple partners and they developed the batteries. And by using that batteries, now we have the buses which can run on this uh, electrical vehicle. That's called electrical vehicles by using that batteries. Okay. So what is the impact of this one? EV sales surged to over 10 billion units in 2023, up to 1.3 billion in 2015. Okay. It was only 1.3 billion in 2015. In 2023, it is 10 billion. Okay. So extended global EV adoption reduces CO2 emission by 230 metric ton annually. Okay. So that's why we need this EV adoption. Okay. So this is another success story of the collaborative R&D projects because multiple institutions took place in this EV development and that reduces the cost, timeline, and increases the benefit of this. Okay. Then another important aspect of this collaborative research work is that just I would like to share is that I also collaborated with the 22 laboratories for the supercapacitor analysis. Basically, the Cambridge University professors, they shared the data with 22 laboratories all over the world and how to analyze that data. So that only took place on the supercapacitor, and we have done very good interlaboratory study assessment by analyzing the supercapacitor electrochemical data. And this is the one of the leading paper in that one. So interlaboratory study assessing the analysis of the supercapacitor electrochemistry data. If only one laboratory has to analyze the data or develop the supercapacitor, that is not valid, because when we all come together and we do different analysis, then there will be gap of the data analysis, the trust, all these things. And if we all group members from the world come together and work on some particular topic, then trust will be there. That is called as the certification. So this is the some type of certification of the supercapacitor electrochemical data. Okay. Then another thing is that this lithium ion battery work was taken place in 1985 or more before that, okay, during 70s or 80s. But this was complete different people groups. Sorry, just a minute. This research work was done in 1970s or 80s. Only research paper were published, but nobody has took lead to develop this product because this battery is very important. And that time only chargeable batteries was there. In order to do this rechargeable batteries, Sony and Asahi companies come together in 1991 and developed the battery. Afterwards, we can just 1 minute. Sorry. So the research work which was done in 1970s or 80s, it was by the different groups. But when all this we have to put in the one platform and develop some product. So Sony is the company which developed lithium-ion batteries in 1991, along with this Asahi. Okay. After 1991, you can see that it was the chargeable battery that is replaced by the rechargeable batteries. So this type of collaborative work or some ideas that is taken by these companies, and they took the, actually they brought these patents from there. Then they put this patent into useful applications. And after 91, we can see that all the phones, laptops, all these things, they are chargeable. So it can save a lot of energy now. So we can use the laptop for 12 hours, 20 hours, 16 hours. For Apple laptops, we can use for 24 hours once we charge. Okay. So that is the innovation. So unless and until we do some collaborative research work, it's not possible to develop these useful applications. Okay. So this is importance of this one. This is another case study is that CRISPR gene editing collaboration. In this collaboration, universities like UC Berkeley and MIT, and for biotech companies like Itidas and Intelligia, they are involved in this one. So, what is the impact of this collaboration? They enables precise editing of the genes to treat the diseases like sickle cell anemia. Then, clinical trials showed 90% of the success rate in the alleviating the symptoms in patients, and they can treat cancer and others and sickle cell anemia. Okay, so if we the universities like this UC Berkeley and MIT and some companies like this Editas and come together to edit the gene and treat the very dangerous things like cancer and sickle cell anemia. So this is a very important collaboration. This is one of the important thing. Okay, so all this possible only by collaboration, open innovation. So, role of the funding agencies. Okay, why we need the funding agencies? For example, for promotion, funding enables the export the new ideas and technology across the various disciplines. Unless and until the promotion is there, then it's not able to have the collaborative collaboration for the new ideas or develop the new technologies with this one. That is possible by the funding agencies only. Okay. Then encouraging the collaboration. These funding agencies will encourage the collaboration. For example, while funding, they will tell that we have to fund 3, 4 team members across the countries. Okay. So that will foster the participation among the academia, industry, and government to tackle the large scale challenges. For example, MahaEV is one of the important uh, innovation in this one. Okay. So for that, they made the 3, 4 team members. For example, ISC, IIT, CSIR, they have to come together to work solve the problem of the MahaEV. Okay. And they can grant 100 crores for that MahaEV solution. Okay. Then building the infrastructure. These funding agencies can support for building the infrastructure. For example, investment in the labs. For example, COVID-19 labs was one that is very important for this one. Okay. Then equipment, research facilities, provide the necessary tools for the advanced research. Okay. So these funding agencies can promote, then encourage collaboration, then building the infrastructures. Then not only this, they will provide the fellowships, grants, and scholarships to cultivate the workforce. For example, for research scholars, for RAs, for scientists, they provide the scholarships for that. Okay. So automatic that is human resources development. Then beside this, while providing the funding to the some teams, they will make the policy alignment. They'll provide the policy for that. By supporting strategic areas or for example, energy, healthcare, all these things, agencies align the research efforts with the national and global needs, such as renewable energy, healthcare, and digital transformation. So, okay. So these are the very important things. And how many funding agencies are there in India? For example, Department of Science and Technology, their goal is completely different than the Department of Biotechnology. Their goal is completely different from the Science Council of the Science and Industrial CSIR. Then ICMR, Indian Council of Medical Research, then Science Engineering Research Board, then Defense Research and Development Organization. This is basically developed the tools for the defense persons, army, navy, and all these things. Then Ministry of New and Renewable Energy, this solves the problem of the energy. Okay. So aim and scope of the funding agencies. For example, if you take the Department of Science and Technology, their aim is to promote the scientific research and technology development and innovation for the national progress. Okay. And what is the scope of their support basic and applied research, promotes international collaboration and innovation ecosystem. For example, is DST provides a multinational or multi-countries collaborative research funding also. For example, DST JSPS is one of the things. Okay, I have that research grant. It will support the scientists to travel to Japan and stay there. And JSPS will provide the support to Japanese people to come to the India and stay here. Okay. So this is multi-international collaboration, their engagement in that. They encourage capacity building and skill development. This is the scope of that, okay, for the DST. Then key program, SCRB. Then Inspire. This is one of the important things, innovation in the science pursuit of the inspired research. For example, this provide the inspired fellowship for the students, faculties, all these things. Okay. Besides this will help to grant the very big projects like technology development programs. For example, 100 crore, 2 crore, 10 crore, like. Then mission innovation. This is very important funding key feature of this program. It started with this DST. Okay. Then what is the structure of this? This operates under the Ministry of the Science and Technology. Then comprises multiple autonomous institutions, research units, and funding agencies in this one. Okay. Then DBT, this is related to biotechnology, right? So to harness the biotechnological tools for social and industrial benefits. And this will support, what is the scope of this? Research in healthcare, agriculture, environmental biotechnology. And this will promote the startups and internships and transfer research. Okay, this is the scope of this one. Then what are the key features? Key features will be Biotechnology Industry Research Assistant Council, that is called the BIRAC. Then Grand Challenge India. Then National Biopharma Mission to develop the new drugs and to tackle with the new healthcare things. Okay. Then what is structure of this? Part of the Ministry of the Science and Technology. Then collaborative with the research industries, institutions, universities, and industries. Houses of autonomous institutions like NIM, NIMG and NCCS and BCIL. Okay. So these are the institutes very well known for this biotechnology, DBT. Then I mentioned about the CSIR laboratory, this very old uh, institutions, okay, funding agency. So what they will support? The aim of there is to advance the scientific knowledge and develop the industrial technology for the social and economical benefits. Okay. Then what is the scope of that? That is multidisciplinary R&D for the social and industrial needs and public-private partnership to scale the innovation of their product. Then the key programs will be CSR innovation centers. There are a lot of centers all over this India. The New Millennium Indian Technology Leadership Innovation, NMITLI. Okay, these are the key programs. And mission mode project. They will focus on one research topic and they'll provide the grant for that. And they have to deliver the goal for that. Okay. Then structure an autonomous body under the Ministry of the Science and Technology. Then manage a network of 37 national laboratories I already mentioned. Okay. So this is the CSIR. Like this is Indian Council of Medical Research. So the main aim of this is to advance the medical research and adding people, public health challenges in this one. And by doing this, the scope of this will be support the international research and healthcare innovation, and that will promote the collaboration with the national and international agencies. And the key program will be external funding schemes, and then biomedical innovation funds, then disease control and prevention programs. The structure of this will be operates under the Ministry of the Health and Family Welfare, and this will include 26 national lab industries focusing on various health challenges. Okay, so each funding agencies they have different aim and their scope and key programs. Okay, like this SCRB also they have the to promote the basic and applied research in the science and engineering, and they will scope is to support both early career and established researchers. Then encourage national and international collaborations. Then key features will be NPDF, then high risk reward research innovation this one, and this also work on the DST under the DST. Okay. So this is one of the important funding agency in the India, DRDO. So design and develop the advanced technologies for the national security for defense purpose. Then the scope of this will be defense system and materials. Basically, this is one of the leading this one. Then space technology and dual use innovation for the most of the satellites and all these things that will be taken care by the DRDO and ISRO. Then key program will be NPDF, then other things are there. And under this 50 plus companies are working on this DRDO projects. Okay. Then funding agency called MNRE. This is basically renewable energy and new energy systems to promote the renewable energy technologies for the energy security and sustainability. This is the aim of this one. The scope of this will be R&D in the solar, wind, bioenergy, and hybrid technologies, fostering energy innovation and ecosystems. Then key features will be National Solar Mission. This is one of the important things. And you know already know that large amount of the solar panels are installed in the Gujarat, and that will creating a lot of energy from that solar mission. Okay, that's what is called as the solar mission. Then renewable energy research and technology development programs. When we give the subsidies to the people, then all that subsidies coming from the MNRE. Okay. Then biomass power projects. These are the very important things. Basically, the structure of this is the function under the Government of India, then collaborates with the agencies like the SECI, Solar Energy Corporation of India, and IREDA, that is Indian Renewable Energy Development Agencies. So these are the some development agencies. Okay. So integrating approaches for the open innovation collaborative R&D. This is cross-agency collaboration program like impacting research innovation and technology. That is called the imprint. That started in 2020. Then Uchitar Aviskar Yojana. This also started recently, and this connect the academia, industry, and funding agencies. Okay, so industry academia interactions. This is Virak, TDF, and CSR, NMIT, and offers the platform for the technology transfer and scaling of this one. Okay, then international partnerships like initiative like Mission Innovation Clean Energy for the clean energy, and global innovation and technology alliances like Gita and support global R&D. Okay, so this all comes under the open innovation and collaborative R&D work. So what are trends in the global funding? So global growth in R&D expenditure, R&D spending has consistently increasing and reaching approximately 3.3 trillion dollar in 2023, and up to 2.4, it was 2.4 trillion in 2020. Okay, so this increase in 3 years a lot, from 2.4 dollar trillion to 3.1 dollar trillion. Then digital distribution. United States largest share contributes 28% of the global R&D spending. In China, significant growth announcing 25%. In Europe, maintains a strong presence of the 22%. And rest of the words about 25%. In corporate contributions, corporate R&D spending suggests to $1.2 billion in 2023, reflecting an 8.3% nominal growth, and shifting the landscape. This is another important trends in the global funding R&D. Shifting landscape, the number of the UK firms among the top global R&D spenders decreasing from 118 in 2013 to 63 in 2013. Okay. US and China lead with 681 and 524 companies respectively among the top investors. Innovation ecosystem resilience. In despite economical challenges, global R&D investment remains robust, emphasizing its critical role in innovation and technology advancements. Okay, where India stands in this innovation and R&D. Okay, so in this global innovation index that is called the GII. Okay, so India ranked 40th in 2023. So in 2015 it was 81st. Okay, so in from 2015 81st is now 40th in 2023. So in global innovation index. And how much the R&D expenditure in this one? So GRD is about 0.7% of the GDP, lagging behind the global leaders like USA and China. So corporate sectors contribute 37% of the R&D spending, lower than the global average of 65%. So what are the research output of this one? India ranks third globally in the research publications. For example, more than 3 lakhs publications. and in PhD awards in science engineering. And India ranked sixth globally for the patent and all these things. So more than 30,000 patents granted in 2022. And in global share, India and other lower middle income companies increased their global R&D share from 3% in 2020 to 5% in 2023. Okay. So slowly this middle income company economics, they're increasing the share in this marketing. This is so much problem. So what is the impact of this innovation? So this will faster the innovation cycle, access to external expertise and technologies accelerate the development of the new product and services, and that will impact the society. For example, Protector and Gamblers Connect Plus development, this model reduces R&D cost by 60% by this open innovation. Then cost efficiency, sharing the resources and knowledge, as already explained, reduces the redundant R&D spending. And for example, this Siemens saves millions annually by integrating ideas from startup via its innovation platform. Okay, so they invite the ideas from the other startups, and by doing that, they will save billions of the dollars by using that. Then commercial success, collaborative with the external stakeholders improves market readiness and adoption of the innovations. For example, this Tesla is the open patent encourages collaboration and accelerate the electrical vehicle adoptions. And by using that, now we have the electrical buses in the market. Then socio-economical growth. For joint effort addresses globally challenges with the climate change, healthcare, and renewable energy. And one of the example is the COVID-19 vaccination. This was the multiple collaboration and open innovation. So what are the benefits of this one? So technological domain benefits mostly in the renewable energy and sustainability about 20%, and semiconductor and electronics about 18%, healthcare and biotechnology about 15%, automotive and transport about 12%, then AI and ML about 10%, agriculture and food will be about 8%, materials science and nanotechnology about 8%, then space exploration about 5%, then cybersecurity about 4%. So by doing this open innovation and R&D, these are the benefits in the different sectors. Okay. So what are the platforms that support the open innovation? Crowdsourcing, this is, Centuve and Kaggle and Herox. These are the one of the crowdsourcing. Then open source softwares, GitHub, then SourceForge, then OpenAI. This supports this one. Innovation networks, this Eureka networks, FS6 and Open Innovation Community. Then University and Research Institutes. This is one of the MIT Innovation Park, then Stanford University Park, then Craig Research Centers. This is one of the institute that support this open platform for the open innovation. Then innovation hubs and incubators, Y Combinators, then Techstars, Station F, that is in Paris. Okay. Then Idea Marketplaces, then Idea Scale and Spiceit. They are the open platform, the open innovation that support this one. By effective collaboration, to foster the collaboration, how to foster the collaboration? For this, to improve the communication. This is one of the important things. And while developing some ideas or giving some ideas, we should be very transparent. This is most effective for the collaboration. Then while doing this, all the team members should be get involved this one, get everyone involved this one. And while doing this, we should not discourage someone. So we should always encourage all the team members to work collectively for the innovation or implementing the ideas. And another thing is that when we have some problems, we should get rid of the walls or what the barriers are there. That we should get rid of that. We need to tackle the problem of that. Then, in order to implement all these ideas, we should always have some frequent meetings of the officials and what is the current stage and how to go further with that one. That's very important. So for this, collaboration tools are very important. We should use the collaborative tools and keep our team happy and motivated always. Okay. So this is a very important for the fostering the collaboration nationally and internationally. So what is the role of the AI and digital platform? So this will provide the autonomous system, then machine learning, deep learning, neural network, pattern recognition, then neutral language processing, chatbots and real-time motion analysis, virtual companies, then real-time inverse translation through collaborative gaming, next generation cloud robotics, the autonomous surgical robotics, robotical personal assistant, cyber security and computing, all these things. Okay, so this will provide the role of the AI and digital platforms. So what is the future scope of this open innovation? So this will provide the systematic approach. This will provide the strategic alignment, and this will also provide the efficiency and resources optimization, and this will provide the competitive advantages. This will provide the customer centric, then adaptability and resilience, continuous in the improvement in our ideas. Then this will provide the employment engagement and empowerment and future proofing of the business of this one. Okay, so these are the few innovation, open innovations. So by industry academia collaboration, we have a lot of applications of this one. This will provide the gradually employment technology transfer, innovation, then large framework funding, and this will involve the academia, business, industries, and government, all these things to develop the product for the social benefits. So what is the key takeaway from this open innovation R&D? Access to the diverse expertise of the team members. They can develop their ideas and product in this one. Then accelerate by doing that, we can accelerate the innovation, and that will reduce the cost and efficiency, increase the efficiency of that one, and decrease the risk control, and that will enhance the commercialization and social impact of this one. Okay, so these are the key takeaways from this. Okay, so with this, I stop my lecture here. Any questions are there, then I'll be try to answer that questions.
Thank you, sir, for your insightful and thought-provoking talk. Now let's open it up for the questions. Participants are requested to ask the questions. Either they can type the question in the chat box or they can raise the hands.
Hello, good evening, sir.
Hi, good evening.
Yeah, sir, it was very nice presentation, the informative session. Only one query that I'm having. I'm Dr. Vijaya Pawar from Bharati Vidyapit Pune. Though you have elaborated the prominent, I can say, R&D collaborators, then also for affiliated colleges, that is for tier 2 colleges,
Okay.
there are very few, I can say, R&D agencies which can provide the funding. So can you please at least tell us few prominent R&D agencies that can provide us the funding for small research projects?
Okay, recently the this government this ecosystem. One scheme that government has, please can you mute your mic? Recently PAIR, okay. So this was the scheme that was given by the government of India. In that, one will be the like IIT or IISc will be the hub with that one. Then university, some government colleges, private colleges, they can submit the research proposal under that scheme. Okay. So now no like DST, CSI or SCR bill, something like that. It will be under the one research innovation umbrella only, only one funding agency in the India. So that will provide the funding agency to all the private and non-private organizations now. Earlier, DST was providing, SCR providing, then DRDO was providing the funding to that one. But now all the funding will be centralized. That is National Funding Agency. Okay, that will provide the funding to all private and government agencies. Also, if you are private or something, then in Indore there is one organization. Okay, that is a DAE or something. Okay, so that will provide the facility for the collaborate work.
There is one question in the chat box. What about open source software?
Open.
Open source software.
That always you can use. There is no problem. But while using that, you have to take the permission from the original provider. Okay. That is the copyright will be with them. You can use and just you can tell that I want to use this software there. And while using that, while citing your research paper, you should cite that.
Okay. I hope sir is clear. Faculty ID 101. The question was from faculty ID 101.
Sir, I want to ask one question.
Yeah, please.
I am Dr. Sanjay Kurkute from Pravara, which is near to Shirdi, Maharashtra.
Okay.
Here actually I am looking after as a CEO of a Section 8 company where we are running all these innovation, incubation, research and startups activities.
Okay.
So while working this, actually your all this focus was very clear to us, and we want this presentation also from your end. Can we get this presentation? And then in case in future if we want some kind of a guidance or any discussion interaction with you, we want your details also.
Sure. We can share.
Okay, sir. Thank you.
Thank you, sir.
Actually, I want to elaborate more things, but because I am not, my health is not good, so little bit I made it fast. I'm sorry for that.
Is there any other questions from the participants? Anyone want to ask? Okay, if not, Ubar ma'am, can I have a vote of thanks?
Yes, ma'am. You can go ahead, please.
Good afternoon, ma'am.
Yes, who's there? Any question from the participant?
Yeah, ma'am. Good afternoon. This is Dr. Ali Abdul Mawjood Muhammad from Iraq. Actually, I was a PhD student at Shifaji University in India. So me and my friend are as a participant in this FDP. I would like to thank the coordinator and the teachers for such an excellent presentation. So we are very interested to learn more information from teachers from other countries. So I did my best to participate in this program.
Yes, sir. Thank you so much. Any question
Yeah,
from
my
your
voice
side,
is
sir?
elaborate, ma'am. Sorry.
Yeah, it is clear. Any question from your side?
Yes, ma'am. I want to ask how can the collaborative research between the academic and the industry uh, accelerate the innovation and the benefit for society?
Okay. So actually, when we have in all this academician, they are very good in the some. For example, I am material scientist. I can develop very good quality material, and industrialists they are very good for the making the device or bringing that device into applications for marketing. All these things. Okay. So I am good only in research, but I do not know how to bring that into the market. So industry person can fabricate the device and bring to the market. So because they are very expert in that one. So if only I have to develop my product, then it's not so easy. But if I give my material to them and they can develop the product and bring to the market, so that's easy. That's why we need the collaboration of the academia and industrial persons. And that's lagging in India. A lot of industries they do not collaborate with academicians, okay? And if we can bring together all together, then that will be good innovation.
Okay, thank you very much, sir. Thank you for a very nice question, uh, answers from your side. I would like to thank you very much.
Thank you.
Thank you, sir. If there is no any question from the participants, we'll come to the vote of thanks. Okay. As we came to the end of this enriching session, I would like to take this opportunity to express our deepest gratitude to Professor Dr. Parashuram Shirge for his valuable insights during today's expert talk on open innovation and collaborative R&D. Professor Shirge, your talk has been truly inspiring. You have not only shared us your expertise, but also highlighted the critical importance of collaboration and openness in driving innovation. The way you have emphasized the role of collaborative research in solving real world challenges has been both insightful and thought provoking. Your vast experience spanning multiple prestigious institutions and international collaboration is a clear testament to the immense value of teamwork in advancing scientific discovery. We are especially grateful for the practical perspective you shared on fostering cross disciplinary partnerships, industry academia, collaboration, and how open innovation can lead to breakthrough solutions. Your work continues to inspire us to think beyond traditional boundaries and focus on creating synergies that benefit both society and environment. We look forward to more such opportunities to learn from your vast knowledge and expertise. On the behalf of organizing committee, I would like to extend my heartfelt thanks for your time, your thought leadership, and for guiding us through the importance of making research more accessible and collaborative. Thank you, sir.
Thank you, madam.
Thank you
Thank you
so
very
much.
much for your nice words. It was a pleasure to deliver a talk in FDP.
Hello, sir.
Thank you, sir.
Hello, hello.
Please share your email ID and your contact details so that we will be in touch with you.
I think madam has shared,
Thank
but
you,
I
sir.
will check it.
Okay.
It's
Okay.
written at the last or not.
Okay.
I will share with you, sir.
Okay, okay, fine, madam. Thank you very
Thank you.
much.
Thank you.
Thank you, sir. I
Thank
request all the participants, there is a break of 5 minutes. We'll join after 5 minutes. Thank you.
thank you, madam. Can I leave now?
Yes, sir.
Yes, sir.
Thank you.
Okay, thank you, madam.
Jokare, sir.
Yes, ma'am.
Second speaker has joined. Sidramappa Dharne, sir. You just make him co-host.
Yes, ma'am. Sir is now the co-host. Ma'am.
Madam.
Yes,
Nevaya,
ma'am.
madam.
Shall we
You
start?
can start now. Yes.
Okay, ma'am. Good evening, all. Let's move on the next phase. I welcome our guest of speaker, Dr. Siddaramappa Dharne, for this online ATAL FDP Day 5, second session. He is a scholar, innovator, and academician who has skillfully brought about a confluence of research and academics, enveloped with societal approach, leading towards resolving real-life problems. I would like to introduce you all to our today's guest of speaker. It is my great honor to introduce to you distinguished scholar, innovator, and academician, Dr. Siddaramappa Dharne, with ME in Civil Structures and PhD in Civil Engineering. Dr. Dharne is a proud member of Indian Society of Technological Education and Institute of Engineers. His dedication to academia and industry has earned him numerous accolades. With over 25 years of teaching experience, Dr. Dharne has impacted countless students at renowned institutes. His academic excellence is also reflected in his 3 successful GATE qualifications with an impressive All India rank of 454. Dr. Dharne has played a pivotal role as a technical service provider for World Bank funded Jal Swarajya project in Maharashtra. He has authored 34 research papers and holds 70 patents, 23 of which have been granted, alongside 8 granted design patents. His innovations span water management, renewable energy, agriculture, and earthquake resistant structures. As a consultant, he has collaborated with the prestigious institutions like Punyashlok Ahilyadevi Holkar, Solapur University, guiding projects and research in civil structures. His work not only drives progress in engineering but also supports sustainability and improvement lighting standards. Among his accolades, Dr. Dharne received the Water and Energy Excellence Award in the UAE and was honored as a special guest at 2024 Republic Day Parade, a testament to his impact. Please join me in welcoming Dr. Siddaramappa Dharne, a true pioneer in engineering innovations. I welcome you, sir. Now, I invite Dr. Siddaramappa Dharne for the expert talk on the topic innovation, sociology, and psychology. The mic is over to you, sir.
Thank you. Thank you. Thank you for such a nice introduction. So first of all, I thanks to my government, ATAL Innovations, and organizing institute and all the organizers. And I welcome all the participants. The today's topic assigned to me is innovation, sociology, psychology, and patents case studies. Here I have taken all my patents as a case studies. And related to that, I will explain what is the innovation, what is the sociology behind it, and what is the psychology behind it. At the same time, what is the psychology behind the commercialization of the patent also. So, just I want to bring some granted patents, granted as well as published patents related to water. As we are getting sun and air, sunlight and air at free of cost, but at the same time, we are getting rain also, but there is a scarcity. So to address the problem of water scarcity, so first innovation come into the picture, and it is a granted patent. Simple and effective method of groundwater recharge. Thereafter, second innovation, these innovations are related to water. I clubbed in one page. Second, water sustainability and flood control. This is also a granted patent. Third, smart urban and rural water supply by using existing resources to address the low water pressure and to avoid the waterborne diseases. This is water patent. Fourth, zero budget water supply for various purposes, domestic, industrial, agri, etc. As farmers are facing many more problems related to water scarcity, how to extract water from the water scarce borewells also. As well, there is a interruption of the power supply. To address that one, I filed this patent and it is published. Thereafter, I come to know that if there is a less rainfall, how to use the structure designed for zero budget water supply for artificial rain. Thereafter, 24/7 water supply by using screw conveyor system. So, in near every farm, or if you take 4 to 5 farms, there are some nalas, small streams, rivers. But during rainy season, if there is a gap of rain and crop requires the water for the irrigation, the farm do not have the sufficient quantity of the water in wells as well as borewells, but in nalas and streams, there is a muddy water that we can use by using screw conveyor system. As well as to address the problems of the boulders in borewells. If boulders are there, we are not using any kind of the pump in boulder area. So that small boulder particles can be extracted along with the water, and we can make use of that water also. This is what a upper smart submersible pump and accessories for uninterrupted water supply. The main problem addressed is a continuity of flow. Whatever the flow we are getting in the borewell from the nature, say it is Q inlet. If you want to take outlet, that is the Q outlet by using various kinds of the pumps. If we are taking outlet discharge is more than the inlet discharge by installing higher capacity of the pump, which are designed for maximum capacity. Especially what happens during summer season or drought, there is a fluctuation of water. So to avoid that fluctuation of the water, I tried many more times, many more experiments I did, and so thereafter I come to know that why we should not design such a submersible pump which do have different capacities of pump which are connected electrically parallel.
Sir, sorry for interruption. Hello. Sir, can you play this PPT on full screen, sir?
Oh, okay, yes, sure.
At the bottom where the charging percentage is showing, there is a button, sir, to play this. Left side of the charging percentage, sir.
Sir, go to slideshow and then from the current slide.
Yes, I will do that.
And sir, Dharne sir, whether you are sitting below the ceiling fan?
No, sir, but computer do have that noise.
Okay, there is a small disturbance in your voice. I thought it is because of the ceiling fan. That is why I just asked you to check.
But fan in the CPU is running. That's why there is this.
Okay, fine.
Now the slides are okay, sir, which is visible on full screen.
Oh, thank you, sir. Thank you. Seventh one, smart submersible pump. So in this smart submersible pump, I have used the sensors also. So we can make use of maximum discharge as well as minimum discharge as per the inlet supply, where we can save the electricity also. The main aspect of this granted patent is to get the water and to save the energy. Suppose water is not also available, so we want to carry water from far distance. Object carrier has been designed on uneven path, multi-wheel chain or belt. So just we have to take chain or belt. On that chain or belt, wheels are arranged. Wheels do have the capacity to rotate about horizontal axis as well as vertical axis, so that we can make use of this chain or belt to carry any object, especially spherical, cylindrical in form. Now, if water is available, what is the next step? That is the use of optimum quantity of water for irrigation purpose. That's why I designed subsurface drip irrigation system. This is also a granted patent. In this patent, we have to supply the water directly to the roots of the crops as well as liquid manures. It is simple, very simple it is. In front of pump or motor, I use one non-return wall. At various places, I use the necessary walls, and to avoid the suction in the pipe network, I have used one more non-return wall in the vent pipe. The vent pipe is provided to avoid the bursting of the pipeline because of suction pressure and sucking of the soil inside the pipe network. Thereafter, I come to know that what is the next step? Subsurface drip irrigation with aerations. To avoid the decomposition of the roots of the crops, I used one air compressor, and we can supply the forcefully air inside the pipe network before irrigation, in between irrigation, as well as after the irrigation, we can clean the pipe network as well. So these two patents can make use of existing water, whatever the existing water we are getting from the above patents, or available water we can say, and that is to be optimum. Because of this, these two patents, yield of the crops will increase, and we can supply liquid manures also, and whatever the unwanted growth of the grass or weeds at the surface of the farm is there, that will not grow, because it grows when soil or gets moisturized and it gets the sunlight. So there will not be moisture on the surface of the farm, because as we are supplying water directly to the roots of the crop. Now, what is the next? Water is available. Now, subsurface drip with aeration is also available. Zero budget sugarcane. But this patent is not granted in as per the welfare of the welfare of the farmers. So I will elaborate everything related to our topic. So in this, I kept sugarcane vertical by drilling the holes. Even we can make use of semi-fertile land, and we can get more yield from this sugarcane. Almost from 1 acre we are getting 40 tons, but from this concept we can get minimum 80 to 120 tons, and we can make undulating ground also. Suppose valley is there, all these ground we can make use just by keeping outlet of that pipe at the same level. That is the irrigation method. We can make use of dead end system like a water supply system in the villages or grid system as per our need. So This is related to water. Now, some more patents. Everything is available. Water is also available. This is also a granted patent. A biocompound and an apparatus for water purification. Suppose you want to drink the water purified, which is purified biologically. This is also a granted patent. In this patent, we have used banana stem, lotus, etc., as well as alum, which can disinfect the uh, biological materials, or it can be disinfected. Thereafter, I did one experiment in my farm, sustainable agriculture seeds for smart farming. As seeds available in the packets are very costly, I did this experiment by keeping in view of our culture, which is the best culture and best festival, one of the best festival, that is Dashara. So I took multiple seeds and just I thrown on the farm, and I did the I, I used the rotor for that one. So because of this, whatever the seeds will grow, that is the sustainable. Same seeds we have to use in the cycles. So in this, what will happen? It do not require soil testing, as well as whatever the seeds we are purchasing from the market, whether these seeds are best suited for our farm or not. Because whatever the seeds are developed in the research industries or research farm, same environment, same water conditions, same irrigation conditions, same fertilizers may not be available. That's why I did this experiment. It is also not granted, but it works. Now, related to above, effective method to convert non-irrigated land into irrigated land and water supply. We can convert non-irrigated land into irrigated land by using above principle, and this was not granted, but I incorporated the concept of this converting non-irrigated land into irrigated land in water sustainability and flood control. I have taken in sequential order. Okay, here instead of going for very deeper depth of the borewell, just we have to take a smaller depth of the borewell, and whatever the water is available, we do have the system to extract that water. So suppose we are going for 1000 feet of the borewell, instead of going for 1000 of the feet of the borewell, just take 300 feet borewell on the periphery of the farm, connect it and extract the water. That system is available, and here we can make use of water scale borewells also by various principles which are explained in above patents. So just I going in sequential order, though I have not filed in sequential order. Now here I use sustainable agriculture seeds for smart farming. Various seeds, mixed cropping I have used, and because of mixed cropping, yield of the crops increases. Now, after harvesting, all whatever the material or product is available, it is in mixed form. To do the gradation, I have developed one method, product, and collection of spiral sieving materials and thereof. Just we have to use the spiral sieve along with belt conveyor and silos and bunkers to collect the graded products. Even we can use this system for various purposes, even for in civil engineering or anywhere we can use. Basically, I got this idea related to agri only. Thereafter, we got the product. We want to live in a good house, so slabs are there. So I enhanced the behavior of RCC slab with different shaped profile of the reinforcements. This is also a granted patent. So RCC means reinforced cement concrete slabs. Generally, we are providing steel or reinforcement to take the tension as per the tension developed. Generally, it is on sagging or hugging side. So I changed the profile of the reinforcements. I made it rectangular trough, P-trough or triangular trough, trapezoidal trough or curvated trough in alternately in both the directions, so that the reinforcement comes in both the direction at top as well as bottom everywhere. So slab will act as a doubly, and in the reinforcement there will be the in-plane forces or membrane forces will develop. If you take the example of GI sheet, corrugated GI sheet, corrugated AC sheets, that plate action will come, okay, in the reinforcement, and that is to be in both the direction. So there will be the enhancement of the behavior of the RCC slab. Thereafter, reinforced cement concrete slabs act as a one-phase material. So to enhance further strength, we can make it ferro cement slabs. Ferro cement means ferro means it is not a type of cement. So in this reinforced cement concrete slab and ferro cement slab, the basic difference is it is a one-phase material and it is a two-phase material. Here we have to use fine wire meshes along with the matrix at top and bottom, and in between whatever the reinforcement is provided for RCC, that will act as a skeleton. So because of this various strength, all strength, load carrying capacity, all load carrying capacity, moment carrying capacity, flexure, shear, deflection, shrinkage, or creep, or impact, all strengths will enhance, as well as impermeability of water. Because generally RCC slabs are facing the problems during rainy season, it will not face the problem. RCC and ferro cement bubble deck slab. In this is the RCC, whatever explained hence before. RCC and ferro cement slab is there, but at neutral axis, concrete is not effective. So we have to create the bubbles by using HDP balls or recycled plastic balls. So weight will reduce whatever the slabs casted by using this method can float even in water also, and its strength is more than the all RCC slabs. So next, again advancement in the slabs, composite and RCC. Composite, RCC and ferro cement grid slab. Whatever the profile of the reinforcement, bubbles, everything is same. But if I want to use, it is for large column free area. For example, theater is there, classroom is there, hall is there. In that, civil engineers used to go for the hidden beams. Instead of going for the hidden beams, I use the tubular sections of the made up of pipes. So again, it enhances. It is also a granted patent. So just to understand in better way, I made the sequence. Then enhancement of efficiency of solar dryer. Whatever the agricultural grains we are getting, because we do have the water, we are going for the cash crops, house is also available. So solar dryer. Existing solar dryers are there. Just I try to enhance its efficiency by using arrays of the convex lenses. We have to keep on the solar dryer, as well as we have to use the arrays of the convex lenses on solar tubes, wherein air will get heated. So automatically efficiency will get increased. Now, if we think about the rehabilitation or low cost housing, so two-way folded plate, two-way folded plate to enhance the load carrying capacities of the roofing elements. In this, the various roofing elements, especially, are taken as GI sheet, AC sheet, plastic sheets. Even we can go for RCC also. So it is just like a uh, chessboard. Black means up or bottom, and white means uh, down or up. That means it is in reverse direction. We have to give the folds. Alternative folds we are getting in both the directions. That means two-way folded plate action will come. So we can go for large column free area. Depending upon the transportation facility, we can manufacture two-way folded plates, and only one single plate we have to keep on one structure. Especially if you take the apartment or any small house, it needs. Even if we use these two folded plates, two-way folded plates at top and bottom in opposite directions, and if we give the connection to the water tank and water is supplied inside these two folded plates, automatically water will get heated if it is GI sheet, and hot water will go in the tank and cold water will come inside the uh, these folded plates, and whatever the room or structure is constructed, that will remain cool always, as well as further to enhance the efficiency of these water uh, water heater made up of two-way folded plate. We have to use again one glass which is having arrays of convex lenses. Just we have to keep on that one, or we have to go for embedded system in this one. Now, this is what we can make cold rooms or structures cold from top. But what about from sides? So, bubble bricks. Bubble bricks. This means this is what is bubble bricks, but it is made up of concrete. If you take the example of reinforced cement concrete column and PCC column, always RCC column do have the more strength. So these are reinforced concrete bricks. But if I am going for the reinforced concrete bricks, its cost will increase. So to reduce the cost and to get the sound and thermal insulation properties inside this one, I use recycled plastic balls or pipes or cylinders. This is also granted pattern. Thereafter, one step ahead, eco-friendly reinforced concrete block, hollow concrete block. In this one, reinforcement profile is different. Here we have changed the reinforcement profile. Yet it is not, it is published, but it is not granted. Then once again step, one ahead step, eco-friendly ferrocement hollow concrete block. To avoid the entry of water inside the building in heavy rainy area, we can go for this eco-friendly ferrocement hollow concrete block. And especially application of these three, we can make use of in a very for school, colleges, where a lot of noise is available, is there, and as well as we can go for high-rise buildings to reduce the weight of the bricks, and these are very cost-effective as compared to autoclaved aerated concrete blocks (AAC). Now, optical system to enhance the efficiency of solar photovoltaic panels. घर तो बन गया है, अभी लाइट That's why optical system, solar panels, its efficiency is again enhanced by using using arrays of the convex lenses. It is embedded system or a detachable system. Just we have to keep on that solar photovoltaic panel, or in embedded system also we can manufacture new solar photovoltaic panels. So these are very simple. It is also granted one. Then what is next? Suppose we want the hot water in the inside the building. So an efficient solar thermal receptor array for water heating. Same principle. Here water is getting heated, here light is concentrating, and here air is getting heated. This is also a granted patent. So this is the one combination. Then house is available, yield of the crop is getting more. Then we have to play now. Then sport bats with enhanced striking capability by adjustable center of percussion. So in this bat, at stroke area on backside, all bats, sports bats चाहिए. If you take cricket bat, on backside of the stroke area, I use small mercury tips. Because of that, in general language, we can say there is a hammer action and its striking capability will increase. This is also a granted. Now, reinforced concrete slabs and beam structures for buildings and bridges for reversal load. क्रिकेट खेलने के लिए जा रहे हैं व्हीकल से, तो ब्रिज आ गया, वो ब्रिज की भी स्ट्रेंथ बढ़ानी है. सेम प्रिंसिपल, एंड इट इज आल्सो ग्रांटेड. और कॉरुगेटेड वगैरह जो बताया ना, दो डायरेक्शन में प्रोफाइल ऑफ द रेनफोर्समेंट. देन बीम्स एंड कॉलम्स विथ शियर रिइंफोर्समेंट एंड स्टिरप्स. बीम्स में जो रहता है उसको शियर रिइंफोर्समेंट, नहीं तो स्टिरप्स बोलते. कॉलम में जो रहता है उसको टाइज बोलते. In various shapes we are using this one. So for taking tension and compression, tension, we are providing the bars in beams, anchor bars, and to take shear there is a separate bar, vertical bars. So instead of going for that one, just we have to make the box. If it is box and made up of box of made up of the reinforcement, and just we have to pour the concrete in that one. Automatically what will happen, in plane forces will develop because of space truss action in the beams and space tower action in the column. Granted, simple. Innovations are always simple, and it works. Earthquake resistance structure. Now, suppose as I am from the earthquake prone region, so earthquake resistant ferrocement hollow columns and cavity wall. So just we have to make hollow column and cavity wall, and we have to fill it by sand. That's it. Granted patent. So what will happen whenever the earthquake force will come in one direction, automatically whatever the sand is filled inside the column or cavity wall, there is opposite pressure and there will be the counterbalance. Now next, all structures are constructed, and village is formed. So earthquake resistant overhead water tank is required. So it is similar to the same water tank, but its foundation is a little bit different. We have to go for the raft foundation. That means at base there is a slab. Then there above there will be the columns. Up to ground level we have to come, and up to ground level we have to fill it by sand again. Same principle as above. So it is just like a dumbbell. Then next, RCC and ferrocement railway slabs, sleepers, and road pavements. So whatever the slabs up till now designed, these were for flexure, shear, and deflection. But RCC and ferrocement railway slabs and sleepers. Suppose you want to go by using the bullet train, so its speed is more. So generally what will happen, because of high speed, whatever the ballast is there below the sleepers, it will not remain in same position. Always maintenance problem will be there. So it is a ballast free sleepers. It is just like a slab sleepers and road pavement. So what is the basic difference? Same profile. So this is the alternative for pre-stressed concrete slab sleepers. These are very cost effective and these can sustain impact loads. So but maintenance problems will also solve. It is cost effective. We can go for cast in situ or precast also as per our need. Then रोड्स हो गए, रेलवे हो गया, अर्थक्वेक रेजिस्टेंस स्ट्रक्चर है, घर में ठंडा बैठना है समझो. सर्कुलर एयर कूलर विथ 360 डिग्रीज इफेक्ट विथ एक्स्ट्रा कूलिंग इफेक्ट. सेंटर में क्या है, जो कूलिंग एलिमेंट है उसके बाजू का फैन, सेंटर के कूलिंग एलिमेंट से जो भी पानी आता है उसके नीचे भी एक कूलिंग एलिमेंट है, सर्कुलर है, उसको भी हॉरिजॉन्टल ब्लेड है. What will happen? Whatever the water will come up on the central cooling, just like it is a sponge or any material, it will drop and fan on the periphery with some gap will rotate along the vertical axis. Same vertical blade of each vertical blade is connected to horizontal blade also. So what will happen? Horizontal blade will throw the water, cool air in a vertical direction, and vertical blades will throw the cool air in horizontal direction. It gives the extra cooling facility. Now, after filing this patent, I come to know that why Himalaya, whether it is works. So, multi-purpose cooler with air heater with 360-degree effect come fan. Same. Instead of using cooling water, I have used heater in that one. So it works. These are the published patents. This is also published patent up to 30. Now next, everything is there, and whatever the crops we are growing and we are getting the more yield. So cost-effective method of storage of onion and agricultural grains. We can store onion and agricultural grains for longer duration. Generally, there is a problem for the farmers, though they are getting the yield, how to store that one for longer duration. So generally, onions are storing in storages by providing air, entry of the air from the sides or bottom or from top. But here I have provided the air inside the onions by using perforated pipes in perforated flexible pipes. Just we have to use these perforated pipes and welded wire mesh, which we are using for ferro cement or various purposes. So that welded mesh, inside that welded mesh, we have to insert that perforated pipe along with the onion in spiral form of that perforated pipe. It may be one, two, or multiples depending upon the capacity. We can store agricultural grains, and we have to supply air forcefully by using air compressor. I have filed 4 patents on that. Here we are forcefully air we are supplying from the air compressor, but suppose there is no any electricity. That air compressors works on the wind energy. Suppose air compressor is also not there, vacuum, that is also not there. Just we have to use the reciprocating pump and it works on the vein. Automatically, whatever the air is inside the onion, that will be sucked and it will be thrown in the air, and whatever the fresh air is there, automatically it will go inside the onion. And for that, I use additional watertight structures and all this. ये सब हो गया. अब पढ़ाई करना चाहिए ना. Triangular rollers के. Suppose, and it is a file patent. It is just like a roller scale. It do have 3 legs. On each leg there are 2 scales. We can use for various engineering purposes, for architectural purposes, etc. And now, this is the last. Though I am having more than 80 or 85 file patents, and this is 36. Our tradition, culture, etc. Kumbh Mela, Mahakumbh Mela, enhanced efficiency of large-scale ferrocement biotoilets. So, holy places or there we can use this is large-scale ferrocement biotoilets. Okay, this is brief about these granted and published patents. Now, first I will go to one more slide, then I will continue. Whatever the 23 patents are there, I have circulated this PPT or YouTube video to each and everyone. I think you have received that one. So how to go for the commercialization? All links I have given. Commercialization of patents and development thereof. I have taken all the patents related to water, flood control, agri, onions, whatever I have been explained. All patents are ready to commercialize. We can commercialize the patents which are granted, even published also, by multiple licensing, except government, for fast and one individual development. Is it okay? I think it is okay. So for that, I am developing the system by my own, wherein many more thoughts I am getting. So related to this, please ask questions, then I will go ahead. So I request to the organizer, if there is no any question, I will continue. So I will prepare the Google form. I will elaborate. What is this one? Google form. That Google form will reach almost all schools in India, but and thereby I can go for the commercialization. But I am getting the question, as my all patents are Indian patents, other countries can make use of these patents. So I have not filed PCT and all these things. So duplication is avoided only from my brothers and sisters. So I have put one mail to the government. So that question was partial, and after clarifying my thought, so this is what idea, psychology or sociology, what country, this is the thought of. It is at national level. So first hold is the applicant, second hold should be country's hold, so that it can prevent the other countries. As a source, it is only up to that level. It is not so deep, but because of that one decision, whatever the granted patents, filed patents, published patents are available in my country or in any country, that will enhance the economy of that particular country. For that, it is also necessary to go for statistical analysis. What are the basic requirements and many more factors. and availability of the patents, available patents, whether these are the related to particular country or PCTs, there are, it is applicable for all the countries. Second option, the patents which are filed and granted in other countries can be used for the entrepreneurs which are not applicable for our country. This is also the idea. We can make use of that patents for startups. We can make use of that patents for NGOs so that we can enhance the economy or many more solutions. Just these are the ideas. So accordingly, we can grow now. So I think these PPTs are already given. Water sustainability, groundwater case studies I have given. So let us see our focused area. Innovation. Innovation is very simple. Whenever idea sparks, we have to go ahead, get it ahead. That is the innovation. Innovation in the context of sociology and culture refers to process through which new ideas, objects, practices, or values are introduced and accepted into the society for cultural growth. That is innovation. Innovation is defined as being born from unique thinking. And where we are getting the unique thinking, as you know, I have filed many more patents and many more are granted also, and these are developing, these will develop total agree also. These are challenging to river linking projects as well as dams. These are so cost effective. So the patents of patent, I want to tell you, just to serve the society and grow. Nothing more than that. Psychology and sociology. That is the psychology, sociology, both are considered social sciences, which are disciplines, social science. I will not go in detail, just okay. I will skip this one. Psychology and sociology. The sociology and innovation highlights first the structure arrangements, characteristics of social networks, organizations and institutions. These are the various factors or points that influence innovation. And second, the relative nature of the innovation. Whether an object is considered novel depends on one's vantage point. These are the various factors. Innovation is defined as process of bringing about new ideas, methods, products, services, or solutions that have significant positive impact and value. So it is very simple for learned as well as those who are having the logical minds, and everyone is intellect. Some are fast learners, some are slow learners, but whenever there is a problem related to any material, any instrument, any process, there itself there is a solution. And if we use that solution, that is more strong and simple solution. I have used all existing resources. It involves transforming creative concepts into tangible outcomes that improve efficiency and effectiveness or address unmet needs. Innovation. So let us see. So basic one, innovation, creativity and ideas. So to develop this one, what I am doing, I am thinking like a 3 years old child. Because if you see the childs or kids, these are very, very creative. So if you give one stick, they will play in different ways. If you give the mobile, they will try to learn it. Learning ability is more as compared to old age people. So creativity, creativity, we have to bring it by thinking the solution of each and every problem at grassroots. So automatically ideas will develop. Culture of innovation. There are various culture of innovation. Uh, uh, this I have not studied more in detail, but whatever the cultures are available in itself, innovations uh, are inbuilt. One step we have to go ahead. We have to add our uh, recent technology in that one. Automatically, innovation will come into the picture. It depends upon the resources and infrastructures available. As I told and before, available resources we have to use so that it will become cost effective and it will become more simple. Leadership and vision. What is the vision? That vision plays very important. Suppose I want to file the patent, but what is my vision? That is what important. So, as I stated, I explained hence before, uh, patents related to water and agri. My vision is just first let complete country and globe should get developed. Automatically, money will come towards me, and it will reach to each and everyone. So it one कल्चर का एक ये है, संस्कृति में दिया है, गणपति सरस्वती को पसंद करो, लक्ष्मी ऑटोमेटिक आएंगे. Effective risk management. So it is very simple. As related to my water and agri-related patents, effective risk management. What is the risk? There is no any risk. Because as I am making these patents open means for commercialization. Let them to develop. So what will happen? Corporate study will happen, research will happen, and upgradation will also happen. So what is the risk? That will come to know. So I am making open means there are some conditions also. Then feedback and adaptation. So I am preparing the Google form for this one also. So how to commercialize all agreements and all these things, whatever the input, how they want to buy the patents or how they want to get it commercialized, they should write. So simple Google form in upload, all forms they should supply to us because researchers do not know that one. Because one person cannot do everything. So just collect the information through the Google form. Then as we are giving the tender of any civil engineering structures, just we have to give the tender thereafter. वो भी टेंडर का क्या करना? This is the idea, and it will generate into the innovation. Though it will not get patented, but this is the business idea. उनको टेंडर कितना चाहिए? Whether they are going to do the complete agri of whole nation or 1 acre, 2 acre, depending upon their capacity, they should submit the tender. Let them to submit the terms and conditions. Then we will go ahead by taking or without taking security deposit, earnest money. This is not my direction. Okay, and it is not. This is not the basic idea. Yet it is not far more. So types of innovations. If you are, these are the various types of the innovation. Hence before the previous resource person explained open innovations. If anything is there, any innovation, though these are the 10, these are the types of the innovation. So, while filing, whenever we are getting the idea, we should think about all this. We should reach so that that patent or ideas will become more stronger. Suppose how to go for the business, technology innovation. What is technology? What is digital innovations? We should think in all the directions. Though these are the different types, these are not separate. Okay, these are like a body, our health. So there is, though there are the specialized doctors, so we have to become ourselves as a specialized one in all the fields. These are the various. I will not read that one. Already process innovation, product technology, etc. Okay. So innovation steps. These are 7. We can increase also. Identity, opportunity. Whenever we are getting identity or opportunity, then generate the ideas. So everyone gets the idea. Definitely, if they do have developed the problem solving logic in their mind, automatically ideas will get generated. Evaluate, select the idea. After getting the idea, search, develop, evaluate and select the ideas. So develop and prototype, then test and iterate, implement and scale up, monitor and evaluate. Then again continuous process is there, research and development, again same cycle. Because it is a continuous process, it won't stop. Otherwise, another patent will come into the picture. As you know, various examples, okay, of various patents. Okay, what is invention sociology? An invention refers to object or concepts. Initial appearance in society. It can be thought of as the creation of product or introduction of a process for the first time. As you know, product, process, tool, equipment, etc. comes under invention. Which are known previously unknown but existing aspect of reality. Now, what is the psychologist of invention or psychology of the invention? So it depends. There is no same psychology which relates to various patents. Though I am the single person, my psychology varies patent to patent, method to method. So that we have to consider, take into the mind. So it is far better not to study it is in detail, as it varies patent to patent as well as operational methods as per the market need, everything. Person to person and even time to time also. The relationship between innovation, sociology and psychology and patenting. Originality, patenting and sociology. The study of innovation sociology looks at how connections, culture and social structure affect innovation processes. It investigates how organizational dynamics, collective knowledge and societal norms influence the development, filing and utilization of patents. So, societal norms, for example, some patent, if you take the example of section 3 of the patent, you will come to know that. Okay. Important ideas in innovation sociology that pertain to patenting, collaboration, and social networks. So, as I told, it varies patent to patent. But if we try to work at the ground level, so it is very important to work at the ground level. We do have the concept of let us grow together, and we as well uh, first let the development should happen, then automatically money will come. Anyhow, the patentee do have the right. Okay, this is not my concept, my sociology, my psychology. So up till now, whatever the patents I have been filed and got it granted or published, I have not referred any literature. I have gone through the problems and I put my whatever the available knowledge to solve the problems. That is the simple. And here, henceforth also, we'll take the concern, opinions, and we'll go ahead. Institutional and organizational influence. This is also very important, and it plays much more important role. Institutional and organizational influence, system for patenting and intellectual property, protection have built by government agencies, universities, and large corporations. Who patents? What gets patented? It is defined by the government. Okay, and the effectiveness of patenting tactics can all be impacted by sociological dynamics present in the nation. Welfare of the farmer, section 3. But I want to bring two examples. COVID-19, we got the medicine. So at faster rate, that patents were free, I think, as per my available knowledge, and even my nation, government of India, have supported South Africa to cure, I think, some disease like cancer. Okay, institutional, including incentives, power dynamics, and resource distribution. So, after all, psychology plays very important. How we are going ahead, how government agencies or government policies are there. So, as I told hence before, what are the rules and regulations? So, here I do have that video. I will share that video if I get it one on group also. Cultural aspect. Views on patenting and intellectual property vary throughout culture and nation. For instance, fields, open source models, or group knowledge sharing may be more valued in some countries. Individual innovation and patenting may be more valued in others. It varies. Patenting practices are impacted by these cultural variations. Even it varies person to person, not country to country. Even if you take individual, patent to patent, idea to idea, it varies. Patent tickets and industry practices in certain sectors such as biotechnology and electronics, the development of dense patent tickets, a complex network of overlapping the patents. So it happens. may have an impact on business choices. To file for patents, sociologically speaking, this might be interpreted as a tactic or dominant markets, or even demonstrate innovative leadership. It depends. Whatever the hence before explained that types of the innovation, on all these factors depends. So, who will study all these factors at ground level, he will dominate these factors. This is my way. So, because one should have that knowledge. Okay. Conclusion related to this. In addition to being legal or technical endeavor, patenting is also social and psychological process that is impacted by a number of variables. So I want to tell you the motto of education and patent, as I told hence before, to serve the society and grow. Nothing more than that. Understanding how social networks, organizational influences, and cultural elements shape patenting habits is made easier by the sociology of innovation. The psychology of innovation, on the other hand, investigates the unique attitudes, incentives, and mental processes that propel inventors to file for patents. Now, I will take my own example. I started to file the patents in 2014. I was not knowing that after commercialization I will get the money. Yet it is not commercialized, but to ascend the reputation of the institute. Then I come to know that we can commercialize that. This is what my history. By demonstrating the ways in which institutional, societal, and human elements interact during the patenting process. This is also very important. These viewpoints collectively aid in our understanding of the larger context of innovation and intellectual property. So, this is the conclusion. So, these are the case studies which are granted and published patents, wherein this PPT are already I shared. Focus area. May I explain this one? Anybody? Okay, I will go ahead. Problems addressed related to water. There is a climate change. I will go to back slide also. Total water sustainability. This is across the country and globe. So, how to achieve this one? First, groundwater recharge. So, how to recharge? Go for groundwater recharge, rainwater harvesting. Roof rainwater harvesting we are doing, but on roof we are not getting the ample quantity of water. But in river streams, ample quantity of water is available. So that is going west, and because of that there is a flood. So same principle we have to use, where ample quantity of water is available in rivers, streams, nalas, etc. It will control the flood. At the same time, groundwater table will come up at a faster rate. Flood control. So it will control the flood, especially in the cities. If you will go for the smaller depth of the borewells, along the sides of the roads, railways, etc., there will not be the flood in cities, because whatever the water is accumulated or getting from the rain, directly it will go inside the ground and it will reach to the aquifers below the ground. Below the ground there are streams, etc. But how to control the major flood? So major floods, suppose rivers are perennial or carrying floods depending upon the season. So from that same principle, but we have to go for the deeper depth of the bore wells. So we have to cut the pashan or pakka mota layer. So water will go at a deeper depth, and it will, what will happen because of this? Uh, it will stop or it will minimize the landslides as well. Because of this groundwater recharge and flood control, this principle, whatever the soil nearby the structure at the foundation level, it will remain dry. As soil remains dry, its shear strength is more as compared to the wet soil. Landslides will avoid, and we can save the lives during floods as well as in landslides also. So, as I explained, artificial rain come and it is not come and 24/7 water supply, and we can make use of whatever the water is we are getting artificially or from ground subsurface drip irrigation methods. What is the basic concept behind it? Whatever the surface water we are getting from the dams, so this water is a stored water. But whatever the water we are getting from rain, this is a pure. At the same time, whatever the water we are getting from the borewells, from smaller depth of the borewells, this is also. But if we go from the deeper depth of the borewells, we may get contaminated water. So, this is also focused in this one. So, these are the problems addressed: climate change, water scarcity, summer, uneven rain, drought, flood, power supply or energy required, total cost for major projects. For example, river linking, dams and related structures. This is the major problem focus, because it is not possible to go for river linking or dams. By doing river linking and dams, we cannot supply the water in any each corner of the country or globe. But by using this above principle, we can supply the water that is more pure in any corner of the country and globe. These are the problems addressed. Optimum use of irrigation by above method, subsurface drip irrigation. Power consumption, problems of regular power supply. These are the minor. Initial investment. So as I explained hence before, initial investment required is also more less in my innovations. Repair and maintenance of motor submersible pump. I am not at all using the submersible pump. Cost is saving, initial cost is not. Just we have to insert the pipe along with one non-return wall inside the borewell. We have to use the two double acting reciprocating pump, which are reciprocating by using a rod. That rod is connected to the wind turbine by using yoke mechanism. In case of rotary motion, and in case of oscillatory motion also, I will go through that one hereafter. Electricity and fuel bills. Here I am using renewable wind energy. Muddy water and small boulders in water bodies. Water is available, but water is muddy. I am making use of that one. Small boulders, I am making use of that water as well as boulders. I am bringing all the small boulders at the ground level. water will get clear, and it will become more streamlined. Low water pressure and thereby waterborne diseases. So, uh, 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 every time it is not possible to construct high height of the water tanks, and though water is available, but uh, I, I was staying in Sholapur only. I got this idea from Sholapur. Everywhere it is not possible because we are getting water from uh, Uzni. Yes, but many more boilers are there, and they can work by using my principles. So we have to operate all the borewells at a time in particular region by using one non-return valve at the outlet of each borewell. So automatically pressure will get developed. Outlet of that municipal corporation water supply should be kept at the same level. Everyone will get the equal water pressure. There will not be the pits. Waterborne diseases will not, because many more waterborne diseases are because of pits during rainy season, especially in villages. And the major reason is low water pressure or not getting the water also. So all the problems are, these are the problems addressed and solutions. Probable solutions, these are the patents and patent numbers, application number. If a patent number is given, it means it is a granted, and if application number is given, it is a published patent. So these are the granted patents, simple and effective method I explained. In water bodies or along the streams and nalas, approximately 50 feet. We have to take 50 feet depth of the bore wells we have to take, and we have to fill it by the filter material like paper, sand, etc. Because water is available, and that water will directly reach to the underground aquifers, and there are again streams like a rivers also there. If you cut the water, even we can get underground dams also. I have not seen, but it is. And it is cost effective as compared to all conventional methods of groundwater recharge. It's very simple. Solution is also simple. I got this idea from government of Maharashtra. As government of Maharashtra was doing Jal Shiva, during study, I was studied in riverbed, whatever the rock is available, it is sedimentary. Continuous cementation process is there. Rate of percolation from sedimentary rock, and which is carried out cementation process continuous, rate of percolation is more. I try to increase the rate of percolation, and it is got granted patent number. Yes. And after filing, even I informed or brought to the notice that this is the best method of groundwater recharge to government Dushkal Mukta Maharashtra. Patent number, water sustainability. So here water sustainability means groundwater recharge and method to extract the water from bore wells and flood control. So basic principle, whatever water we are getting. So I will read this one. The basic objective of the present invention, this is the abstract, to provide total water sustainability and flood control consists of uninterrupted effective water supply even from water scarce borewells by using existing resources. It is not necessary to go for the new borewells also. Okay, all existing, there are n number of the borewells So in that borewell, at least 10 liters, 15 liters, 20 liters water is also available. None of any borewell across the country and globe is dry. So as well, effective groundwater recharge, because of this effective groundwater recharge, to bring up groundwater table up at a fast rate, even by using this invention, convert the non-irrigated land into irrigated land by simple and effective method. So suppose in farm there are n number of the borewells, all borewells we have to connect, and we have to use one speed regulator just like a fan regulator. I did that experiment also and it works. So what happens? Generally, farmers are using higher capacity of the pumps to get more water, but it won't happen during summer. There is a fluctuation of flow, and uh, especially three-phase speed regulator or one-phase speed regulator, it is similar to the fan regulator. We have to regulate the speed of the impeller so that automatically outlet discharge will become less than or equal to the inlet discharge. Suppose in farm, if someone want to go for new borewells having smaller depths and more in numbers, instead of deeper borewells, the basic reason behind it, which covers the larger specific catchment area of subsurface flow. This is the main reason. Suppose if you take not 10 acres, 20 acres, if you take go for larger area, its catchment area is also different, more. Like that, I took the example. Also, the invention is to control the floods, especially in towns and cities, by taking smaller and deeper depths of the borewells and filled it by filter material along with the sides of the roads, gullies, streams, rivers, sides of the railway tracks, etc. as per the requirements. There will not be any problem to the railway track also. Okay, it's simple solution. Third patent, so I will read this one also. Patent number, upper is smart submersible pump and accessories for uninterrupted water supply. A smart submersible pump is designed by using various capacities of pump motor connected in parallel and monitored by sensors as per their water level in the borewell. The capacity of pump motors and location of the sensors depend upon discharge capacity available in the borewell. The smart submersible pumps maintain the continuity of flow manually or automatically. As it is monitored by sensors located at different levels in the borewell, the uninterrupted water supply can further be maintained by using speed regulators to the pump motor. I have given one example in that video. Yes. So I will repeat that one also. 10 HP pump 532. All these pumps or motors will work simultaneously when water level is at top or at higher level, and slowly top motor will get stopped and bottom two will work when water level will come down as we are setting the level of the sensors, and bottom pump or motor will work for minimum inlet discharge. But in during heavy drought, there will be again fluctuation. So of the water, to stop that one additional speed regulator. Patent number, drip irrigation. The basic principle of the present invention to supply efficient and optimum water to the roots of the crops by using subsurface drip irrigation. It is simple and effective even in case of water scarcity. The novel subsurface drip irrigation overcomes all the limitations because of present system of the irrigation and keep the merits of all the methods of irrigation cost effective applicable for any soil condition. And here I added, as you know, one additional uh, air compressor, okay, in this one. So here we can supply liquid manure or gaseous manure directly to the roots of the crop. So this is one of the advantage which we are getting in drip irrigation with aerations, subsurface drip irrigation. Application of zero budget water supply. I will read this one also. Disclosure a method of zero budget. I changed the title of this zero budget water supply. But here I mentioned the same one. Come maintenance water supply for various purposes, domestic, industrial, irrigation, etc. The water supply system is useful for any type of water sources. We can use any source, open well, bore well, ponds, dam, etc. Where water lifting is required, the continuous 24/7 water supply is also possible depending upon the availability of water and wind, without any other power requirements. The main principle here in this innovation used to make use of wind power or to convert wind power into rotary motion. Hands rectilinear motion is also focused. And principle of lever arm, minimum energy principle, law of moments, principle of least work, etc. are used to convert kinetic energy of wind power to mechanical energy and thereby hydraulic or potential energy. The innovation is cost effective and can be used in any corner of the country. Suppose there is no any wind, hybrid mechanism. We have to use small capacity of the motor which is operated on any fuel or electricity, or we have to go for pipe. Here, for if you take the example of household or apartment, hardly it requires 20,000 to 50,000 for lifetime to extract the water from borewell. There is no any electric bill. And for farm, the structure is required, so hardly 1 lakh to 2 lifetime. Simple. Artificial rain, same thing, same structure, zero budget water supply. Here at top, we have to fix the high capacity of the nozzles. Nozzles are connected to the pipes of high capacity. Pipes are connected to the underground air compressor. That air compressor is cooled by any means or kept in the say ferrocement cold storage, and we have to cool that whatever the air along with seeding agents such as silver iodide, salt, ice, and other hygroscopic material are used for artificial rain. So this air along with these seeding agents, which is injected forcefully in the clouds by using big sizes of the air compressor simultaneously at a time in the particular region as per need and meteorological studies. Simple. So the same towers can be used for producing wind energy by oscillatory. Here I have taken that is at bottom. So I clubbed. So we are getting the artificial rains. So in other words, hypothetically, you can say our dam is at top. Application number: smart urban and rural water supply by using existing resources So here just the number of borers whatever are available in particular region we have to use along with one non-return wall, and we have to operate at the same time so that we'll get more pressure. And if any borewell is contaminated, we have to change the time schedule, or we have to use separate pipeline. So it will develop water pressure, and unwanted diseases will be avoided. And same principle if we use in farm, that is non-irrigated land. Screw conveyor, muddy water, and small boulders. So pattern number, system of field arrangement for object carriers over uneven path. The invention provides the wheeling arrangement. Each and every wheel do have the capacity to rotate along horizontal as well as vertical axis. Minimum 3 wheels. Whenever obstacle will be there, that wheel will stop, because at a time 2 wheels are running on the floor. Okay, so next wheel come into the picture, and automatically the cycle may get repeated. We can use for various purposes. Whatever baggages, railway platform, chota backhoe, material handling trolleys, wheelchair, kids toys, water vessels carrying on uneven path. So this is granted. So thereafter I got the idea. Object carrier on uneven path just by using multi-wheel chain or belt. Simple belt. Same principle. That wheel, single wheel we have to use here. Which on that belt, which can rotate about horizontal and vertical axis. So number of wheels will be there in series. Like this, we have to use minimum 2 belts or more belts to carry any object on uneven path. Even in agri also we can use these belts to carry any objects. Biocompound and apparatus for water purification. A banana stem and stem of lotus and root extract, alum and activated charcoal is used dissolving into water to clean the water and make it disinfected, sediment free, colorless, and odorless. This is an important thing. So, what are the conclusions and achievements? Very important conclusion: save lives in major floods, minor floods in various cities, controls the major and minor floods in rivers and even in cities. Because of this, we can avoid the landslides. We can save the infrastructures also. Effective groundwater recharge. Water scale borewells can be used very effectively. Whatever available are there, that can be also used. Artificial rain come 24/7 water supply by using single unit or structure. If suppose in farm there are n borewells, n wells, n water sources are available, all can be connected to one infrastructure. This is the great merit. Multiple water sources can be connected to single unit to extract water by using reciprocating pumps and operated on renewable wind energy and hybrid mechanism as per the requirements. In hybrid mechanism, we can go for anything, solar, fuel, diesel, petrol, idling in hybrid mechanism. Renewable wind energy is used effectively. So that I have covered. Optimum use of water for subsurface drip irrigation system. Optimum use we are making. And because of this, yield of the crops increases by subsurface drip irrigation. Many more problems of the farmers as individuals are trying to solve and it will get solved. Total water sustainability, flood control and groundwater recharge works even in heavy drought. Non-irrigated land can be irrigated, converted into irrigated land, and thereby cash crops can be cultivated. Village and municipal water supply will be as per minimum water pressure, and thereby controls the various water diseases by awarding pits to collect the water. Effective use of power supply. So 2 to 3 patents have been focused. First, use the wind energy, or use the pumps or motors in uh, connected mechanically series and electrically parallel, as per the water level by using sensors, or additionally, in case of zero budget water supply, also additional pumps in hybrid mechanism, effective use of power supply. Very less investment and save a lot of money for major projects. Just think on this point. Suppose there is no any dam, there is no any river linking project. This is not challenging. It is not at all required one also. If it is available, we will go ahead. No problem. Very less operational and maintenance cost. Living standard of one individual and economy will enhance. National economy will enhance. Works in any corner of the country and globe in emergency. So complete system is developed. Water vessels or any object can be carried out even on uneven path by object carriers or by using just 2 wheels. Total farming will become enjoyable and ease of life. So the basic principle of any research or education is that life is simple, make it more simple through little bit research and innovation. That I follow. Cost of maintenance and repairs of roads, railways, tracks, etc. will be reduced because of less pore water pressure. Uplift pressure is there, water pressure, during rainy season when water table will come up. Reduces the landslides as explained as before, and save the lives and infrastructure. Achieves the global sustainable development goals. Many more. We are achieving this. Strengthening. This is what important. We are strengthening the existing and new NGOs, startups, entrepreneurs, and giving the new energy to new NGOs, startups, entrepreneurs, and this is the energy to one individual and government, and everyone is government, everyone is farmer. These are the useful links. For case study, I have taken the same thing, though I have given you the video. So these are the for commercialization I explained. If time permits, I do have the energy. May I go ahead? These are patent certificates. Granted patent, freshwater. These are in sequential or alphabetically. So many more are there. I will provide you this PPT complete. Okay, please go through that one. So it is far better. I think you interact, you ask the question, wherein teaching learning will happen from both the sides. It is not one way. So you ask question, I will think on that one. So please, may I stop the sharing?
Yes, sir.
Thank you, sir, for your knowledge on the topic innovation, sociology, and psychology. Now the forum is open for question and answers. I request the participants to raise the questions. Either they can write the question in the chat box or else they can raise the hands.
Better, I request directly question should be asked instead of putting question in the chat box. So please coordinate.
Yes,
Please.
Participants can raise the question if they have.
Dharne sir, this is Dhobre from Orchid. In one of the earlier sessions, one of the speaker told the importance of design IPRs and utility patent. So, can you tell us about when design patents are important, and does it really carries the value?
Sir, each and every innovation, small research do have the value. First thing. Designs are related to shape and configurations. And patents are related to process method, tools, equipment, etc. The validity of the patent is 20 years from the date of filing. Validity of the design is for 10 years. We can extend it for next 5 years, but just by paying 2,000 rupees additionally. Shape and configuration, only shape and configurations. So, as per new draft of UGC, I don't know, got updated that one. For promotion, we require at least 2 utility patents. Am I clear?
Yes, sir. Yes.
So, whatever you are thinking, designing it is not an engineering design. Shape and configuration. Concrete block का shape, bottle का shape, any product का shape और configuration है. और वो product कैसे बनाते हैं वो method हो गया.
There is one question in the chat box from Amanpreet Kaur. Can you tell or suggest some topics?
Pardon?
For patent and research. Can you tell or suggest some topics?
Can you tell or suggest some topics?
Topics, yeah.
Yeah. So it is very easy, sir. So related to our domain, whenever we are going in the or surveying or observing any problem, just put your sound knowledge to solve that problem, and that will be the topic for each and everyone. So it depends on vary from domain to domain. What way of thinking, psychology, sociology, idea, what generates. If same problem is there, number of people can solve it in number of ways. So research gap we have to find out related to societal problems, and we have to provide techno-societal solutions for that one.
Okay, sir. There is one more question from Dr. M.D. Kulkarni from NKOCET. If the patent is not commercialized for few years, what can be the consequences?
The validity of patent is 20 years, but to maintain that one, patent should be in force. We have to pay the renewal.
Okay, sir. Is there any question from the participants? Okay. Thank you all the participants for your thoughtful and introspective questions, which led to the fruitful discussion. Now, coordinator of the FDP, Dr. Panchashila Ubale, is here to give few instructions related to the session. Ubale, ma'am.
Thank you, ma'am. There is one announcement and important instructions to all participants. Announcement is that tomorrow the session will resume at 2 p.m. There will be 3 sessions up to 6:30. Thereafter, we will go for validatory function and feedback. Participants should note that the feedback must be filled on ATAL portal. Second thing is that participant has to check their attendance through ATAL portal up to 25th of January. So the participant need to check their attendance as well as they have to fill the feedback on ATAL portal tomorrow in the evening from 6:30 to 8. It is mandatory to get the certificate. Once you have filled your feedback, you have to give the test. At the moment when you start to give the test, after up to 60 minutes, you have to finish the test within a time. So these 3 things are important to get the certificate. Thank you. Over to you, ma'am.
Thank you, ma'am. The feedback link will be provided in the chat box. I request all the participants to fill the feedback form. Now coming to the sum up of the session of day 5 of the FDP. I extend heartfelt thanks towards our guest speaker, Dr. Sidramappa Dhane, for sharing his knowledge and enriching us with the wide spectrum of ideas. Dr. Dhane, your insights have been illuminated the intricate interplay between innovation, societal dynamics, and human behavior. Through your expertise, you have shown us how sociology and psychology guide and shape innovative process leading to solutions that not only address technological advancements but also serves societal needs effectively. On the behalf of everyone present here, I express our gratitude to you for taking the time and sharing your wisdom and ideas. Lastly, thank you to the organizing team and all the participants for making this session such a success. Thank you all. I request all the participants to fill the feedback form, which the link will be shared in the chat box. Thank you all.